Okay, this is 11.2, second to last video of the entire class. You guys should be pumped up. But anyway, this is going to be the test, and I know that grammatically you guys were making fun of me already earlier, but it's the goodness of fit. Okay, so we're testing to determine if a population follows a semi-specific distribution or normal distribution. So what we're going to be doing in this problem is you're going to be given some type of information about some data, and we're going to see if it continues to follow that pattern. So that's kind of the idea that you need to set up. So the null hypothesis is we're going to assume or think that the population fits it, that it is following the same distribution from year to year, or month to month, or day to day, whatever we're looking at. The alternate hypothesis is we think that there's a difference. Something has changed in the minds of the people that you're surveying or looking at or following. So null hypothesis every time is the population fits. Okay, the alternate is the population has a different distribution, and you might need to specify that particular one depending on the problem. So instead of being a test of independence like last time, or saying something's independent, we're just going to say it follows a given distribution. So what kind of problems will this look like? Basically, you're going to be having like a year-to-year type scenario. You're going to be giving some percentages that previously has happened, or some type of response thing. So in this example, we're going to test if the most important category for employees has changed for like a contract negotiation type thing. So if they went to an employees of some company, or maybe teachers, or whatever you might want to say, is the listing of last year's preferences are given below. So there's going to be percentages from the previous year that are given. That's going to give away the hint that it's the goodness of fit problem. Okay, so the categories that they mentioned are vacation, salary, safety, health, and retirement, and overtime policies. So what you need to do then, once you have this basis, okay, they're going to have some sample. They're going to do some survey for the current employees to test what they think at this certain time. You need to make note of what the sample size is, 500, because what you're going to end up doing is multiplying this 500 to each percentage and getting a number, and that's going to be the expected number, and I'll talk about that in a second. Okay, but it's still going to be a chi-squared. So no different than the first section, you need the same formula. We need to establish what the observed and the expected number is for each individual category. So this is actually, I think, a little bit easier because there's less things to do. So there's only like 5 of the big, long, obnoxious formulas that you actually have to complete. Alright, so before you do any of the work, you need to set up your tests. So we're going to test at the 1% level. So that's your alpha. Okay, if the responses in the bargaining categories fit last year's distribution. So what do you do with the null? You say that the present distribution of responses is the same, or that there's no change, okay? And then the present distribution of responses is different. So something along those lines, but it's always going to be the null we assume is the same until proven different. Okay, so you're going to build a formula type table just like we did before. So what's going to happen in your problem, in your in the actual problem in the book or anything I give you, is they're going to give you the observed answers or results from the random sample. So what this is notice, I remember I circled the 500 people were surveyed. So that's what you observe. You observe what the current people think. Okay? And then that table that I originally had, these percentages, you're going to use these, like I said, 4% times 500, 65% times 500 becomes our expected number, because we expect these things to stay the same, okay, in this goodness of fit type category. So 4% times 500, 20. 65 times 500, 325. And you literally put the numbers in there, and that's how we go about finishing our problem. So now it's no different than section 1, and hopefully this is pretty quick, because observed minus expected is 100 once you square it. So 30 minus 20 is 10. 10 squared is 100. And then you have to divide by the 20. That's where the 5 comes from. And you do this for all the categories. So 290 minus 25 is a negative number, but you square it, get 1225. And you divide by your 325, and you get all 3 of these numbers, or 5 of those actually. For 5 numbers for the 5 categories, you add them up. This becomes your chi-squared. Okay, so that becomes your chi-squared number. So your chi-squared is 14.15. Degrees of freedom, if you look at your formula sheet, it does say for goodness of fit, it's just the k minus 1. All k means is the number of categories. So how many different categories are in your problem? There are 5 of them. So 5 minus 4 minus 1 is 4. So if you look at your chi-squared table, degrees of freedom 4, your 14.15 is going to fall between these two numbers. So then you have an interval. Okay, remember this is a right-tailed test. It's all the information to the right. So that's what our table tells us. And if we now finish this thing, okay, the larger, and I'm just going back to the picture, the larger values of the chi-squared indicate a bigger difference, that it is actually significant. There's stronger evidence to reject the null and then accept the alternate hypothesis. So goodness of fit tests are always right-tailed tests, like I've mentioned before. Before I finish the problem, I want to give a little incentive for those of you that still watch these and go through and work hard. I appreciate that very much. All I want you to do is email me, say have a great day, or whatever else you want to comment on. If you want to write me a comment, that's fine, but just specify who you are in the email, and you will receive a little bonus just from me for taking the time to do the things that you should be doing in the class. So to finish this test, if you go back to your chi-squared table, these were the two numbers on the top of your table, so between 0.005 and 0.01. That's the p-value, and as the p-value gets compared to your alpha, we obviously need to reject. And then what are you going to conclude? Since we reject the null hypothesis, and I didn't include this, we probably should be consistent at the 1% level. Either we have enough evidence or we conclude that the distribution of employee responses has changed. There is a significant difference. Their thinking or logic has changed. So that is it for this section. The homework should be on the very bottom here if I didn't cover it up. And I hope you all have a wonderful day.